All right, first of all, a big overview of all of chapter 8 is all about exponents and powers and how the applications of those. So we're going to be talking about all kinds of powers and exponents. Okay, so the first thing we're going to do is start off with this. It's a property of zero and negative exponents. Okay, so you guys, I know you're familiar with this. So let's go ahead and start filling these out. So we're going to simplify expressions with zero and negative exponents, but first we have to understand what do they actually mean. So 2 to the 4th power. What is 2 to the 4th power? We're going to put out the definition in expanded form. So that would be 2 times 2 times 2 times 2. So what do you get when you have 2 times 2 times 2 times 2?
16.
16. So 2 to the 3rd is 2 times 2 times 2. There's only 3 of them. So what is that?
8.
Then we have 2 to the 2nd, which is 2 times 2, which is 4. And then 2 to the 1st is just 1, 2. So that's 2. All right, so let's look at the simplified versions over here. So 2 to the 4th was 16. And then when we dropped a 2, we went to 8, because what do you do when you drop a 2? We're actually doing what? We're dividing by 2. Does that make sense? So 16 to 8 would be dividing by 2. 8 to 4 would be dividing by 2. 4 to 2 would be dividing by 2. So what's 2 to the 0 power?
0.
What's 2 divided by 2?
1.
1. All right. Now, if we follow that same pattern, 2 to a negative 1 power, that means we're going to divide by 2 again. What's 1 divided by 2? 1/2, which is, we'll just write it like this. Well, we'll get there in a second. Then what's 1/2 divided by 2?
1/4.
1/4, which is really 1 over 2 times 2. And then what is 2 to the negative 3rd? We have to divide by 2 again, which is 1/8, because that's 1 over 2 times 2 times 2. So what do you think 2 to the negative 4th is going to be?
1/16.
1/16. The expanded version would be 1 over 2 times 2 times 2 times 2. Okay, so you guys, positive exponents are repeated multiplication, right? Negative exponents are repeated division. Okay? And then that anything to the 0 power is that weird one. That's just 1. Okay, so let's try 3s. 3 to the 4th is 3 times 3 times 3 times 3, which happens to be 81. 3 to the 3rd, well, that's only 3 of them instead. So this would be, Grady, what's 3 to the 3rd? Grady?
27.
Perfect. And, ooh, and then 3 to the second, what is that? Garrett, wake up. What's 3 to the second power?
9.
9. All right. Brady, you can have the hard one. What's 3 to the first power?
3.
Good. Now, this is actually the really hard one. Caitlin, what's 3 to the 0 power?
1.
Yes. Okay. Then, what's 3 to the negative first power? Oh, let's see. Cooper, do you know this one? What's 3 to the negative first?
Um, 1/3.
Yep, exactly. 1/3. Oh, come on. And let's see. Sean, do you know what 3 to the negative second is?
No, I'm still trying to figure that one out.
All right, so it's like this. This is what it would look like if you expanded it out. So what would that look like then if you simplified it?
One to the 9th.
1/9, exactly. All right, let's see who hasn't had a chance. Braden, what is 3 to the negative third?
1/27.
1/27. And then 3 to the negative fourth, Sophia.
1/81.
All right, now this is all good when we have this nice table that we can just keep going and we have that in front of us, right? But what happens when we don't? So let's take a look first of all at our observation. It says, what pattern do you notice from the symbol this? What did we do at that symbol? Do you remember what we did?
We divided by 2.
Divided by 2 on this side, and over here we divided by 3, correct? Okay, now how should we define 2 to the 0 to make most sense? I don't know.
Since there's no 2's to multiply it by, it's just, never mind.
I know it's hard. 2 to the first divided by 2 is equal to 1. I don't know. Maybe that. How should we define 2 to the negative first to make the most sense? Do you remember what I said earlier about thinking of negative powers as being what? Repeated what? It's repeated division. So instead of repeated multiplication with positive powers, well, that's not how you spell it. Okay, this is better. Okay, so these are the types of problems you're gonna have. Well, first of all, let's do this. Any base except 0 with an exponent of 0 is equal to what number? Remember up here? Think of it this way. If I have 285 to the first power, and then 285 to the 0 power, how do I get from the first power to the 0 power?
You divide by 285.
You divide by 285, which gives us
1.
1. So anything to the 0 power is 1. So 7 to the 0 power is equal to 1. 2019 to the 0 power is equal to 1. Y to the 0 power is equal to 1. Okay, now I'm going to throw a little something at you. Just a side note here. If you have -5 in parentheses to the 0 power, what do you think that equals?
-1.
Actually, it means -5 divided by -5. So it would still be +1. That's because of the parentheses. If you have -5 to the 0, like this, without parentheses, then that's really saying -5 divided by 5. So that is equal to -1. Okay. So when you have parentheses, that's holding it in, that gives you a +1. When you don't have parentheses holding it in, it's a -1. All right, just so you're aware. All right, now I need to blow this up a little bit so I can see some of these values better. And I don't know if it's going to make it better or not. We'll see. All right, so any base with an exponent of negative value is equal to the what of an exponent of positive values. So look at these guys. Remember here? 1/4, 2 to the -2 was 1/4, which is what in comparison to 2 to the 2nd? What is 1/4 compared to 4? Anybody know what word I'm looking for?
Reciprocal.
Yeah, exactly. It's the reciprocal. Okay, so when you have a positive exponent, you start multiplying. When you have a negative exponent, you can still multiply, but you have to divide it by 1. So see, 5 to the -2 is really equal to 1/5 to the 2nd. I can't read this. Is that 4 to the -3rd?
Yeah,
Okay. So what is 4 to the -3rd?
1/12.
Actually, it's 1/4 to the 3rd, which is equal to 1/4 times 4 times 4. What is 4 times 4 times 4?
64.
Right. So we actually have 1/64 here. Now, you guys, you could cheat all day long on these numbers with your calculator because your calculator will do this for you. But remember, I'm going to be bringing in variables to this because this is algebra and you're not going to be able to put that into your calculator. So you need to know how to do these by hand without the use of your calculator. All right, so 7 to the -2, since it's a negative, that doesn't mean -7 squared. That's totally different. So this does not equal this. What is -7 squared? Anybody know?
What?
What is -7 squared?
149.
-49. 7 to the -2 is 1/7 squared. So this is 1/49. Totally different numbers, right? Okay, I think that's 10 to the -4th. What is that number? Simplified. 1/10 to the 4th, which would be equal to 1/1 with 4 zeros behind it, right? You guys have questions on this? Is this all good? Okay, I can't see that power. What is it? X to what power?
-8.
Okay, so this would be 1/. x to the 8th. Can I simplify it any farther than this? That's as good as it gets. Okay. All right. So do you guys have questions on this? I know it's totally different. All right. Now this is your homework. This is what we're going to be grading on Friday. So you're going to simplify them so they have positive exponents, or simplify them like simplify them out. So okay, so take a look at 11. What's the power of 3? What's the invisible power of 3?
1,
1. What's the invisible power of A?
1,
1. So we have b to the 0, we have 3 to the 1, a to the 1, b to the 0. Remember, your job is to make positive exponents. Well, 3 and a already have a positive exponent, right? What do we know about b to the 0? What does that equal?
1,
So what's 3a times 1?
3a.
3a, that is a simplified version of this problem. So that's as far as you'll go. Okay? That is what you need to do for the rest of this class period, is work on these 13 problems, because we already did one. I will have my after school Zoom at 2 o'clock if you get stuck on anything, okay? So today at 2 o'clock, I'm not going to have the after school Zoom tomorrow because I'll be gone.